Hi, this is an example problem about standing waves in a pipe, and this is from chapter 17. Pause for a moment and read the question. So this question is about your eardrum, and we're going to model the eardrum approximately as a tube open only at one end. And we want to try to figure out in part A, what is the fundamental frequency of the ear canal? And in part B, what is the next higher harmonic frequency of the canal? To help us out there, we're going to go to a PDF that gives us some equations that describe the harmonic frequencies of waves in a pipe. And there's actually two types that you can have. If you have a pipe that's open at both ends, as you do here, you've got this equation, which is the same as the equation for standing waves on a string. But in this problem, we actually have a pipe which is closed on one end, and that ends up giving us a slightly different formula to calculate the harmonic series of frequencies. And notice that for this one, you actually only get odd harmonics with this equation, 1, 3, 5. And that's basically due to how you're able to fit an additional half wavelength on. You get a quarter wavelength here. Next time you fit an additional half wavelength, so you get 3/4, and another half wavelength to get 5/4, etc. So we can go ahead and use this equation here. All right, so to get the fundamental frequency, of course, that is n equals 1. So for part A here, F1, the fundamental, that's equal to, of course, 1 multiplied by the speed of the wave. This is a sound wave. 343 meters per second is the speed of sound we're using here. Divided by 4 multiplied by the length of the tube open at one end, which in this case 2.9 centimeters. We're going to convert to SI units, 0.29 meters. And when we calculate that, we should get a frequency, which means we should get 1 over seconds or hertz. And the number we get is equal to about 2,960 hertz. And interestingly enough, that's near to the range where human hearing is most sensitive, around 3,000 to 4,000 hertz. Part B. What is the next highest harmonic frequency of the canal? Well, again, as we note that this whole term right here, this is your F1, right? So we can rewrite this if we want for higher frequencies. If we know what F1 is, we can just take that fundamental frequency and multiply by the integer value to get the higher harmonics. Now we can't go to F equals 2 here because this is only odd harmonics as we see here. Therefore, the next highest harmonic is going to be the third harmonic. And so we can go ahead and put in n equals 3 times the fundamental frequency. And when we calculate this, 8,870 hertz. Actually, if you take the number of the fundamental multiplied by 3, you get 8880, but I just used the full decimal values to get a more accurate answer when I did part B. And so what I actually multiplied by was more like 2,957 hertz. And there's your answer for that one.